The reason for selecting 10 amps is because 10% of the 100 amps. Because whether the IEC current transformers guarantees that 10% error up to 20 times of the rated current. So for 100 amps of secondary current, up to 10 amps can flow in the magnetizing impedance and 90 amps to the burden of the CT. Still, we will meet the 10% of the accuracy. So from the excitation curve below, for 10 amps of the excitation current, see the 10 amps of the excitation current, the secondary voltage is nearly to the 90. Since the 90 voltage is greater than the calculated 50 volts, the CT we can consider as an advocate for the relay accuracy. So this is the other way of checking the accuracy of the CTs. But present we are not required. These are the class of CTs which are used in the abroad. For us, no need. Mostly we are checking the performance of CT based on this excitation curve when we require this type of CTs, because you are having one CT, and if you want to check whether the CTs can be applicable for other application, so this is the way of doing the first statement. So this is about the CT thing, CT sizing part. Any doubts, team, on CT? Sizing of the CT. I am sharing you this article as well as the DC component one. If you have any doubts in that, please come back to me. We will discuss on the DC component of that. Any doubts here on the CT sizing? Clear everything? So tomorrow I want to start potential transformer and followed by the bus bar sizing tip. So I want to end the class for today because of less population, less people are joined. We are of team of 10 members. No one joined. Maybe they are busy with some other works. Tomorrow we can continue the potential transformer and the bus bar sizing, which is a rigid bus bar as well as a strain bus bar sizing. So any doubts in the CT, you can please.
Sir, I have a question actually.
Yeah, please.
Yeah, if we select the higher burden, then it will be harmed anywhere?
If it is an higher burden, selecting an higher burden, yes, it will harm to the metering CD. Means just you are checking the overcurrent capability of the metering at downstream, right? At the other end, right? So that should be lower. The current which is on the secondary side should be lower than this. So that is the condition you are checking. Up to that level, you can increase the burden. And come to this relay point of view, the protection class, you are not much worrying about that relay one. You are here worrying about that the fault current, the through fault current, the maximum fault current seen by the CT should be less than the CT, the current at which the CT enters into the saturation. Because the principle of protection CT is to protect the system, and it should not operate for the other zone of fault. Understood?
Okay, but understand, but for the protection, it's not need to worry. We can choose the 100 VA also if we have required only the 5 VA. But for the protection.
No, not. See, again, it's again not you have to go. There should not be much gap that 100 VA. Again, that secondary side will have to take care, right? The relays to where, to whom, to which you are connecting in the protection. Not much margin. A basic margin should be there, where the condition, if you satisfying that condition, it's sufficient. If it is giving a high current, so what it seems, if 100 amps is flowing on the secondary, just to think about the relays which are connected to on the secondary side. That is also one more important point, right? To be noticed. Yeah.